NAT is a process which is used to make communication possible between public and private network. Okay. So in IP addressing we discussed, we divide IP addressing into two parts, right? First we divide IP addresses into classes, and then we divide each classes into two parts, private and public. So if I will talk about the range of private IP address from each class, so here also you can see a range, or you can google it, what is the range of private IP address or what is the range of public IP address from each class, right? So private IP addresses are used for inside network, for LAN network, right? And private IP addresses are free, but public IP addresses are payable, and we use public IP address on internet, right? Private IP address are not routable on internet, public IP addresses are routable on internet, right? So see, in this scenario here, let's say this is side 1, or this is what happened. Yes, let's say this is network of Google. This is network of Google, right? This is private network of Google, right? And inside the Google network you can see there is one server, and what Google want, or this is my private network, what I want to give access of this server to outside user. I want to give access of this server to outside user. Let's say, I have one networking rack. I want to give access of my rack to my student, so that my student can also access my rack from home, or they can configure, they can perform lab, right? Like that, let's say I have something on this server, or I have some books on this server, and I want outside users should be able to download book from this server, right? Getting my point? Like how we are able to access server of Google Google network is also a private network, right? But they have configured NAT so that we are able to access their private server through public IP address. Here I want to hide my private IP address also, like my private IP address of this server is 192.168.20.1, right? But I want to hide this private IP address. What I want, through public IP address, my public IP address is 16.1. Through this public IP address, outside users should be able to access this server. Means if this PC will hit on this public IP address, right, they will access my server. If I will ping 16.1 from this PC, I will not ping this interface, I will ping to server, right? So this can be my requirement, and my requirement can be like, here we have some LAN user, and these LAN users should be able to access internet. So here also we need to configure NAT on router number 1, so that we can make communication between private to public, because this is public network, this is private network, right? Here also we will use NAT, and here also we will use NAT. One minute, guys. Hello. Okay. So it totally depends on types of NAT, that which type of NAT I need to configure on router number 1, and which type of NATing we need to configure on router number 2. So in this scenario I will configure NAT so that this LAN user can access internet as well, and this LAN user can access this server through public IP address as well. Okay, on router number 2 we will configure a static NAT. On router number 1 we will configure maybe dynamic NAT, or we can configure PAT. So we are not using dynamic NAT nowadays, so definitely I will configure PAT on router number 1. Okay, so here also you can read what is a static NAT and dynamic NAT types of NAT. First one is a static NAT. A static NAT is one-to-one translation. One private IP address will be translated into one public IP address, or you can say one public IP address can be translated into one private IP address. Then we have dynamic NAT. In dynamic NAT, guys, we can create a pool of public IP addresses. We can create a pool of public IP address, and private IP addresses will be translated into public IP addresses from that pool. And third type of NAT is PAT. port address translation. In PAT, translation is going to happen on the basis of port. So edge router will assign one source port number and one destination port number while translation. And in patting, all private IP addresses are going to translate it into single public IP address. See in this scenario, let's say in my LAN there are 100 user. There are 100 user. So if I will configure a static net on router number 1, how many public IP addresses are required? 100. 1 for each private IP address. Yes or no? So we need 100 number of public IP addresses for a static NAT. So here we cannot configure. Generally, why we will configure a static NAT here? We will not configure a static NAT because public IP addresses are available. We have to pay to ISP for each public IP address. Like here I have purchased public IP address with /30. If I will purchase public IP address with /24, I need to pay more money to ISP. Getting my point? Okay, but in this private network we have only one private IP address. So here we can use a static NAT. Here actually I have to configure a static NAT here whenever I want to give access of my server to outside user. I have to configure a static NAT, because in a static NAT, whenever R2 will receive traffic where destination is going to be, let's say, 16.1.1.1, so this router will have one permanent entry that always 16.1.1.1 is going to translate it into 20.1, 192.168.20.1. Right, so this R2 will receive a packet where destination is 16.1. router 2 will translate destination from 16.1 to 20.1, and after that it will check routing table, and then router 2 will forward the traffic to server. In dynamic NAT, let's say here we have purchased public IP address with /29, 15.1.1.0/29. Now tell me how many valid IP addresses are there in this network? How many? 6 number of valid IP addresses are there, right? One is assigned over here on ISP side, one is here. That means free public IP addresses are free. So I can create one pool of these 4 public IP addresses on router number 1, and all private IP addresses can be translated into these public IP addresses, right? That means how many user can access internet at a time? Only 4 user can access internet at a time. Let's say in the pool my public IP addresses are 15.1.1.1, 15.1.1.2, 15.1.1.3, and 15.1.1.4. So let's say PC1 have generate one request for 8.8.8. router 1 have translated 10.1 into 15.1. When PC2 will generate reply, again it will translate 10.2 into 15.2, right? For 10.3 it can translate to 15.3. For 10.4 it can translate to 15.4. and now when reply will come of this user, of first user, then only this public IP address will get free, right? So until and unless reply will not come from of user first, no one can send request for internet. If any user will send request for internet, R1 will drop the packet, because now R1 don't have any free public IP address in the pool for the translation. So this is problem of dynamic NAT. Let's say you have 4 number of public IP addresses in the pool. That means only 4 user can access internet at a time. If you have 2 number of public IP addresses in the pool, that means only 2 user can access internet at a time. That is the reason why we are not using dynamic NAT nowadays. We are not using dynamic NAT nowadays. But still we are using a static NAT and dynamic NAT. When you will use a static NAT, when you need to provide access of your server to outside user, when you have server in your network. And when you will use PAT, port address translation, when you want to make communication possible between private and public network, whenever you want to use internet in your LAN. Like when we are purchasing broadband router, right, for home internet connection, so NAT is already configured there. Every time NAT is performing what? Translation. If I will talk about the network design of my home, so everywhere in my family is using internet.
Recording on, right? Sir?
Ye-
Recording on, right?
yes, recording is on,
Okay.
right? All my family member are accessing internet through Wi-Fi router. So my Wi-Fi router is connected with internet, and here we are using one public IP address 15.1.1.1, and all mobiles, laptops, all end devices are wirelessly connected through this router, through this broadband router, and all these devices are using private IP address, right? So this router is performing netting, translation every time. Actually, PAT is configured over here by default. Okay, so static net is one to one translation, dynamic net is one to static net is one to
Many
one
to one,
translation.
huh?
Static net is
Many to
one to,
many.
yes, many
Uh,
to many
yes.
translation, right? Many private IP addresses are going to be translated into many public IP addresses, and PAT is many to one translation. Many private IP addresses are going to be translated into single public IP address. Okay, then as I told you in last class, we have some terminology in that, like inside local, inside global, outside local, outside global, and then we have configuration of NAT. So in this scenario, here we have internet. This is my router A. NAT is enabled over here. Router B, router A, NAT is enabled. This is router B, let's say. So for me, inside local is 10.1.1.10. Inside global is this network. Outside global is this one. And outside local is remote public network. This one. Fine. Then there are some configuration of a static net, dynamic net, and I think SPAT. Okay, so let me configure, guys, each type of NAT one by one in this scenario. First of all, what I will do, I will configure IP addresses on all devices, and I will save the configuration for VPN, and after that I will configure NAT, so that when we will reset the device, IP configuration will be still there. Okay, so let me access R1, R2, R3, ISP, after that PC1, PC2, and server, right? So on server, say no IP routing first, because this is router, and then IP default gateway 192.168.20.100, and interface fast ethernet 0/0, say no set, and IP address 192.168.20.1 255.255.255.0. Exit. Let me write the configuration. Then R1, interface fast ethernet 0/0, no set, IP address 192.168.10.100 255.255.255.0. Exit. Interface serial 2/0, say no set, and IP address 15.1.1.1 255.255.255.252. Exit and write. R2 interface fast Ethernet 0/0 no set IP address 192.168.20.100 interface serial 2/0 say no set, and here IP address is 16.1.1.1 255.255.255.252 exit and write. Then ISP interface loopback 1 IP address 8.8.8 255.255.255.255 exit interface serial 2/0 no set, and IP address 15.1.1.2 255.255.255.252 exit interface serial 2/1 say no set, and IP address 16.1.1.2 255.255.255.252 say no set, right? And let me close the console of ISP because now we don't need to configure anything on ISP router. PC1 IP address 192.168.10.1/24 and gateway 192.168.10.100. Let me check connectivity between PC1 and gateway. Ping 192.168.10.100. So okay, PC1 is able to ping their gateway IP 192.168.10.2/24 192.168.10.100. Fine. Okay, and this server is able to ping their gateway or not 192.168.20.100. So server is also able to ping their gateway. Now first of all I am going to configure static NAT on router number 2. Static NAT on router number 2. On router number 2 interface fast Ethernet 0/0. This interface is inside or outside, guys? F0/0 of R2 is inside or outside?
Inside.
Inside, because this interface is connected with private network. Inside. Exit interface serial 2/0 IPNAT outside. Fine. And to configure a static NAT, command is IPNAT inside and source. Source is going to be static, and then define the IP address of source. Source IP address 192.168.20.1. Then inside global IP address means my public IP address. To which IP address you want to translate this IP address? This is private IP address, and public IP address means my inside global address is 16.1.1.1. 16.1.1.1. That's it. Okay, so IP NAT translation. So you can see this IP address will be translated into this IP address, this public IP address. This is my inside global IP address means my public IP address, and this is my inside local IP address means my private IP address. Okay, so this public IP address is going to be translated into this private IP address, and this private IP address is going to be translated into this public IP address. Always this is one-to-one translation. Entry will be permanent in NAT table. Okay, so from server, if I will ping 8.8.8, ping 8.8.8, ping is not working. Why? I think on R2 default route is not available. IP route 0.0 0.0 exit interface serial 2/0 and next hop IP address 16.1.1.2. And let me check connectivity from R2 to ISP also. Ping 8.8.8. So R2 is not able to ping 8.8.8. From server, let me ping again, and you can see this time server is able to access internet. Server is able to access internet. Now question is, why R2 is not able to ping 8.8.8? Why R2 is not able to ping internet?
We can enable the ICMP.
ICMP.
Mm,
By default ICMP is enabled, brother. This is not firewall.
okay.
This is router. See what is happening whenever router 2 will receive traffic on serial 2/0. So serial 2/0 is configured as what? IP NAT outside. So first router 2 will check NAT table. Router 2 will check what? NAT table. And it will perform translation. Whenever a NAT enabled router receive traffic on their inside interface or outside interface, it's check NAT table. Okay, so when R2 will ping 8.8.8, source IP will be what? 16.1.1.1 and destination IP will be what? 8.8.8. R2 will check the routing table. Inside the routing table, one default route is available towards ISP. So IP route. Default route is available towards ISP. So router 2 will forward traffic to ISP. And you can check that ISP is receiving traffic or not. When I am pinging IP, debug IP ICMP, right? And again let me ping 8.8.8 from R2. See, ISP is generating reply, yes or no. Source is 8.8.8, destination is 16.1.1.1. So when ISP router will receive this ICMP packet, ISP will generate reply where source will be 8.8.8 and destination is 16.1.1.1, right? After that ISP will forward this packet from serial 2/1 because ISP will check the routing table. So IP route inside the routing table for 16 network for 16.1.1.0/30 exit interface is serial 2/1. So it will forward traffic from serial 2/1. When router 2 will receive traffic on serial 2/1, serial 2/1 is configured as interface serial 2/0 of R2. This interface is configured as IP NAT outside. So R2 will check what? NAT table. First R2 is not going to check this is my IP address or this is IP address of another device. First router 2 will check NAT table, IP NAT translation, and inside the IP NAT translation there is one entry that this public IP address is going to be translated into this private IP address always. So R2 will translate source, R2 will translate this destination IP address in the packet. 16.1.1.1 is going to be translated into 192.168.20.1, and then R2 will forward packet to server. It will check routing table, so IP route, and inside the routing table, yes, this network is directly connected on fast Ethernet 0/0, so it will forward packet from fast Ethernet 0/0. That's why R2 is not able to ping 8.8.8 now. But from R2, I can ping 8.8.8 from any other source. From any other source. From any other source, I can ping 8.8.8. But for that, again, netting should be configured on router number 2. So this is a static net. And now you can see server is able to access internet, able to ping 8.8.8. Okay. So in a static net, we have to create one entry for one device. For one private IP address, we have to define one public IP address, which is not possible in case of forwarding traffic from a LAN network to internet. So this is a static net is useful whenever we want to provide access service, right? Whenever we have server in my network And now you will see these outside user can also access this server through public IP address. Through public IP address. What is public IP address of this server? If I want to give access to outside user of the server, so I will distribute my public IP address, which is 16.1.1.1.
Yeah.
So whenever someone will hit on 16.1.1.1, router 2 will receive traffic and router 2 will forward that traffic to server. Okay. And on router number 1, I am going to configure dynamic NAT. On router number 1, I am going to configure dynamic NAT first. So to configure dynamic NAT, first of all, IP NAT pool. I need to create one pool. The name of pool is, let's say, CCNA. And in this pool, you have to define range of public IP addresses. Range of public IP addresses. Let's say my starting IP address is 15.1.1.1 and end IP address is 15.1.1. Let's say 5. Net mask 255.255.255.0. Okay. So here I have created one pool. In this pool, I have defined 5 number of public IP addresses. Okay. And then IP NAT inside. And to define source network, you have to create access control list. So access list, let's say number 10, permit 192.168.10.0 while karma 0.0.255, just for classification of traffic, to classify the LAN. Now IP NAT inside source. This time source is list number 10 and destination is pool. Destination means public IP address is pool. Pool name CCNA. That's it. IP NAT translation. We don't have any entry in translation table, right? So IP NAT statistics. So here is configuration. And now you can check that PC1 is able to ping 8.8.8 or not. Ping 8.8.8.8. It will not work. Before that, I have to configure one default route towards ISP. IP route 0.0.0, 0.0.0, exit interface is serial 2/0, and next of IP address is 15.1.1.2. And from PC1, let me ping 8.8.8. Still ping is not working. So IP NAT translation. Oh, interface fast Ethernet 0/0 IP NAT inside and interface serial 2/0 IP NAT outside. Right now PC1 is able to ping 8.8.8, and on R1 if you will check NAT translation table, so IP NAT translation, you can see this is IP address of PC1. This IP address is translated into this public IP address 15.1.1.1. 15.1.1.1. Now let me check PC2 is able to ping 8.8.8. Yes. And again on R1, this is public IP address for this private IP address. But guys, we are not using dynamic NAT nowadays because in this configuration only 5 users can access internet at a time. Only 5 users can access internet at a time. Okay, so let me remove dynamic NAT configuration from router 1. Do so, run section IP NAT, say no to this pool. First no to.
Yeah, sir. Can you ping server?
Yes, I can ping server. Ping 16.1.1.1. See, I'm able to ping server. I'm not pinging router 2. I'm pinging server. If I will ping private IP address of server, ping 192.168.20.1, it will not work. As I told you, communication between private to private over public is not possible without VPN. So this ping will not work. Destination unreachable, because router router 1 will forward traffic to ISP and ISP will drop the packet, right? But through public IP address I'm able to access server. Okay, clear, Dana?
Can you do trace route?
Yes, we can. From see, from R1, actually on VPC I don't know what is the command for trace route. So from router I can trace 16.1.1.1. See, this is IP address of router 1, this is IP address of ISP, this is IP address of router 2, and then router 2 is forwarding traffic to server. See, private IP address is hidden, right? We can't see private IP address of server. Okay.
Can you show the NAT translation in R2?
R2. So on R2 NAT translation will be same. Entry is permanent here. So IP NAT translation. Okay.
Okay, sir.
Now we will configure
NAT using the UDP protocol.
UDP protocol.
Here UDP showing R2.
UDP? This one?
Yes.
Trace route is UDP.
Trace route is UDP, correct.
Where trace route?
Can you ping from PC to
I have
server?
trace route na this IP address from PC number 1.
If
Yes.
you do it, do trace ping from PC to server, it will show here, right?
Sorry,
Can you ping from PC to server?
PC2 to server? Trace or
Yes.
ping?
Ping.
Ping 16.1.1.1.
Now can you show the NAT translation in R2?
Okay. Here now protocol is ICMP.
Yes. So for trace, it's UDP. For ping, it's ICMP. Both are showing here.
Yes. Okay. Now can I remove dynamic NAT configuration from R1? Nowadays
Will
we
you
are not
give
using
overload in dynamic NATing? That IP route, if you give overload,
IP NAT inside source list 10 and pool CCNA overload. We can use this feature also here.
what is the difference? What is the benefit of using overload here?
No, this is extra, feature available here.
In the production, they use like this.
Yes,
Uh,
they don't like this. They like this only.
no, overload only they will use.
Overload will use in PAT,
Oh,
port address translation.
okay, sir.
Okay, so let me remove dynamic NAT configuration. Do so run section IP NAT, say no to this. Pool is in use, so we can't destroy it. Then we can run, I think, clear IP NAT translation command, translation star, and so IP NAT translation not able is empty. Now let me try to remove this command, and no to this also. Okay, do so IP access list. So we have one access control list where we have defined the source network, right? Now here we will run this command IP NAT inside. Again, source is going to match from list number 10, and public IP address will be the IP address of interface serial 2/0, and then we will use overload keyword. Overload keyword will enable actually PAT, port address translation. Okay, and ping 8.8.8 source fast ethernet 0/0. So IP NAT translation done. This IP address is translated into this public IP address 15.1.1.1. when PC1 will ping 8.8.8. So PC1 IP address is 10.1.1.1. Sorry, 192.168.10.1. This IP address is translated into this public IP address 100. 10.100 is again translated into same public IP address 15.1, right? If PC2 will also ping 8.8.8 on R1. See, 10.2 is also translated into same public IP address 15.1. So here all private IP private IP addresses are going to be translated into single public IP address, and from PC number 1 again I can hit server through public IP address 16.1.1.1. Yes, I am able to access server. So this is, guys, netting. Clear?
Any PAT overload is there? Overloading of PAT.
Overloading of PAT. Overloading of PAT means?
If you are trying to access the more and more clients of
Yes, for each client it will assign one source port number and destination port number. According to that, R1 will perform translation on
maximum
the
port
basis
number
of port number. Maximum port number is 65535.
for IPv4,
Yes, for IPv4.
for IPv6.
Don't know. You can Google it. What is the range?
Okay. Okay.
Okay. Now let me restart the device.
In cloud also same thing, na?
Yes, in cloud also same thing. Now, guys,
For
I
example,
want
if
to
we required more than 65,000 connections, then how we go?
more than 65,000 connection. So you are
Yeah.
saying in your LAN network there are more than 65,000 client. You have
Yes.
more than 65,000 client in your LAN. Okay, I will check what is the solution for that. Okay, now see how to make communication between two private network over public network. Okay, let's say this is site 2 and this one is site 1. Okay, so here we are going to create one tunnel between R1 and R2, and see first theory part what will happen in this scenario. In this scenario, if PC1 want to ping this server, right, through private IP address, let's say from PC1 if I will ping 192.168.20.1, right, so source IP will be 192.168.10.1 and destination IP will be 192.168.20.1, right. PC will forward this traffic to their gateway, to router number 1. Router 1 will check their routing table. In their routing table, one default route is available towards ISP. So router 1 will forward traffic to ISP. But here if we will have one tunnel between R1 and R2, right, and I will configure, let's say, one static route on router number 1 like IP route 192.168.20.0 255.255.255.0 and exit interface is, let's say, tunnel 1. Here I have created one tunnel 1 interface, tunnel 1 interface, right. So router 1 will make one entry in their routing table for this network for 192.168.20.0. Exit interface is tunnel 1 interface, right. So this time router 1 will exit traffic from tunnel interface, and whenever router 1 forward traffic from tunnel interface, it will encapsulate one extra IP header. It will encapsulate one extra IP header. And in extra IP header, when you will create tunnel here, you have to define tunnel source and tunnel destination. So tunnel source on router number 1 will be my public IP address, tunnel destination will be remote public IP address, right. On router number 2 also tunnel source will be my public IP address and tunnel destination will be remote public IP address. So R1 will encapsulate this actual ICMP packet with extra IP header, and in outer IP header it will put tunnel source IP address as a source IP address, that will be 15.1.1.1, and destination will be tunnel destination IP address, means remote public IP address 16.1.1.1, right. Now on the public network, my traffic will flow on the basis of outer IP header, not on the basis of inner IP header. ISP routers will check outer IP header. Inside the outer IP header, destination is 16.1.1.1, which is public IP address, and as you know, public IP addresses are reachable on internet, right. So R1 will again check what routing table. In the routing table for 16 network, default route is available, so it will forward traffic to ISP. ISP will check their routing table for 16 network, exit interface is serial 2/1. It will forward the traffic from this interface. When R2 will receive the traffic, it will check what destination is 16.1.1. 16.1.1.1 is the IP address of R2, so it will remove this IP header, it will open inner IP header, and inside the inner IP header, destination IP is 192.168.20.1. router 2 will forward traffic from fast ethernet 0/0, and this is how server is going to receive ICMP request message. In the same way, server will generate ICMP reply message. Clear? And tunnel interface is like virtual interface, like loopback interface. Loopback is what? One kind of virtual interface on router. So tunnel is also one kind of virtual interface on router. And here on this tunnel, we will assign one IP address also. Let's say here IP address is 10.1.1.1. Here IP address is 10.1.1.2. Both IP address should be reachable with each other. Yes, definitely both IP addresses are reachable with each other. Why? Because tunnel source and tunnel destination are reachable with each other. Tunnel source is 15.1, tunnel destination is 16.1. 15.1 and 16.1 are reachable with each other. That means tunnel IP addresses are reachable with each other. Now here we can configure dynamic routing protocol also, like EIGRP, OSPF. Getting my point, guys?
Why we use tunnel IP again?
to make communication possible between two private network over public network. By default, communication between private to private over public is not possible. The technology which we are using to make it possible is VPN. VPN stands for virtual private network. What we are doing by creating the tunnel, we are creating one virtual network over virtual private network over public network. Okay.
Okay.
Can you
So on
configure
R1, yes, can I?
configure that one, that VPN?
Yeah, definitely.
Okay.
For this virtualization, we need to pay more or how it is? If we
For
you
VPN,
yeah.
yeah, you have purchased one public IP address only for this interface.
Okay.
You have purchased only one public IP address here. This is free of cost. You don't need to pay any extra, money for tunneling. That's why nowadays also we are using it. We are connecting multiple sites together our public network through VPN, through tunneling. This is called GRE tunnel. GRE tunnel means point to point tunnel.
GRE
Okay,
stands
so
for
generic routing encapsulation.
okay.
Generic routing encapsulation. Okay, so on R1, simply so IP interface brief exclude unassign. So we have IP configuration correct, and so IP route we don't have default route here. See how to create tunnel interface tunnel, after that tunnel number. So you can configure, you can create many number of tunnel on router. So let me create tunnel 1. Then IP address on this tunnel 10.1.1.1, let's say 255.255.255.0. After that, tunnel source. Tunnel source is my public IP address 15.1.1.1. Tunnel destination 16.1.1.1 remote public IP address. Now question is 15.1.1.1 and 16.1.1.1 are reachable with each other or not. So do ping 16.1.1.1. I'm not able to ping. Why? Because default route is not available. So I need to configure one default route again on edge router towards ISP. So first of all, let me define IP route 0.0.0 0.0.0 and serial 2/0. Let's say on router number 2 also IP route 0.0.0 0.0.0 and serial 2/0. Right? From R1 now we can check connectivity ping 16.1.1.1, and now you can see both public IP addresses are reachable with each other, right? So run interface tunnel 1. So this is configuration on tunnel interface. Just I have assigned one IP address, I have defined tunnel source, and I have defined tunnel destination. I will do same thing on router number 2 also. Interface tunnel 1, IP address on tunnel interface is 10.1.1.2 255.255.255.0. Now tunnel interface is down, but once I will define tunnel source and tunnel destination, tunnel will come up. Tunnel source 16.1.1.1 and tunnel destination is 15.1.1.1, and so IP interface brief. Now my tunnel interface is up, right? So from router number 1, let me ping 10.1.1.2. So you can see I am able to ping remote tunnel IP address. And if I will capture this link, because my traffic will move from this physical interface, right? From this physical cable, not from the logical tunnel interface. So on this link, if you will see traffic now, so see again I am going to ping 10.1.1.2. See, ICMP request message. This is my actual ICMP request message. After that, IP header, then GRE has encapsulated one extra IP header, and in outer IP header you can see source IP is 15.1.1, destination IP is 16.1.1.1. So always keep in mind, whenever exit interface is tunnel interface, router is going to encapsulate one extra IP header. And in extra IP header, source IP will be tunnel source, destination IP address will be tunnel destination. Because on R1, when you are pinging 10.1.1.2, first router 1 will check what? Routing table, so IP route. And in the routing table, yes, 10 network is directly connected on which interface? On tunnel interface. So exit interface is tunnel interface. So whenever exit interface is tunnel interface, router will encapsulate GRE header. GRE header means it will add one GRE header, after that one extra IP header, outer IP header. And in outer IP header, source IP address will be tunnel source IP and destination will be tunnel destination IP address. And both are now public, so these IP addresses are reachable on internet. So maybe we have multiple router on internet, right? Like inside the ISP there are lots of router. So requirement is both public IP address should be reachable with each other. That's it. Done, guys? Done? Now can PC1 ping to 192.168.20.1? No. Why ping is not working? Tell me why ping is not working. When PC1 is pinging, source IP address is 192.168.10.1, destination IP address is 192.168.20.1. PC1 will forward traffic to their default gateway to router number 1, and router 1 will check what? Routing table. So IP route. In their routing table, is any route available for 20 network? No. So it will use what? Default route. That means it will forward traffic from serial 2/0. Right? It will forward traffic from serial 2/0 without encapsulating GRE. Without encapsulating GRE header, it will forward traffic from serial 2/0 and ISP will drop the packet. ISP will drop the packet. So on router number 1, what I can do, I can configure one static route. IP route 192.168.20.0 255.255.255.0 and exit interface is tunnel 1. Now you can see so IP route. In the routing table, one specific route is available, right? For this network. Exit interface is tunnel 1. So whenever now router 1 will receive traffic where destination is going to be from this network, it will odd traffic from tunnel 1. And whenever router 1 will forward traffic from tunnel 1, it will encapsulate one extra IP header. In outer IP header, source IP address is 15.1, destination IP is 16.1. Right? In the same way on router number 2 also, because still PC1 cannot ping because reverse path is not available. Now R2 will drop the traffic. So on R2 also I am going to configure one static route. IP route 192.168.10.0 255.255.255.0 and exit interface is tunnel 1. That's it. And now you can check PC1 is able to ping server or not. Ping should work now. What mistake I did?
In R1, exit interface is tunnel 2.
Tunnel 1. So IP interface brief. Tunnel 1. This is correct.
2. In R2.
So IP interface brief. Yes, tunnel 1. Let me check the capturing. When I am pinging from PC1 to this IP address, ping 192.168.10.100. Even I am not able to ping my gateway. So IP interface brief PC1. So IP all. Oh, IP address is not assigned here on PC1. 10.1.1.1/24 and 10.1.1. Sorry, 192.168.10.1/24 and 192.168.10.100 is gateway. Right? Let me check server IP address. So IP interface brief exclude unassigned. So yes, now let me try to ping. So now you can see ping is working. I'm able to ping my gateway. Let me ping the server also. Ping 192.168.20.1. So I am able to ping server also. So how ping is working? Actually, source IP address on this PC will be 192.168.10.1. Destination IP will be 192.168.20.1.
இன்னொன்று வந்து
Right?
இன்டர்நெட் போறதுனால பிளைன் டெக்ஸ்டா தானே போகுது, எப்படி என்கிரிப்ட் பண்றதுன்னு கேளு. 2 கொஸ்டின் கேளு.
Yes, Ganesh.
Can you do EAGRP?
Yeah. Just understand first packet flow. After that, I will configure EAGRP also. Okay. So on PC, source IP will be 10.1, destination IP will be 20.1. It will forward traffic to R1. R1 will check the routing table. In the routing table of R1, so IP route, one static route is available for this destination network. Exit interface is tunnel 1. So whenever router 1 will forward traffic from tunnel interface, it will encapsulate GRE header and it will add one extra IP header. Inside the extra IP header, source IP address will be tunnel source IP address. Tunnel source IP address is so run interface tunnel 1. Tunnel source is 15.1.1 and tunnel destination is 16.1.1. So in outer IP header, source IP will be 15.1.1.1 and destination IP will be 16.1.1.1. And then again router 1 will check what routing table. So IP route. So this time a specific route is not available for 60 network, but there is one default route, right? So it will forward traffic from serial 2/0. Right? When ISP will receive the traffic, ISP will check outer IP header. Inside the outer IP header, destination IP address is 16.1.1.1. So ISP router will check their routing table. So IP route, and for 16 network exit interface is serial 2/1. ISP will forward traffic from serial 2/1. When router 2 will receive the traffic, it will check destination. Destination is 16.1.1.1. 16.1.1.1 is the IP address of R2. It will remove outer IP header and GRE header, and then it will check inner IP header. Inside the inner IP header, destination IP is 192.168.20.1. For 20.1, exit interface is fast Ethernet 0/0 on router number 2. For this network, exit interface is fast Ethernet 0/0, so it will forward traffic from fast Ethernet 0/0. Right?
Here outer IP address is it's okay. That is 15 and 16, right? And what about
Right.
this GRE header? GRE header, actually, what it includes in that?
GRE header will, okay, let me tell you. When this PC will encapsulate ICMP packet, right? After that, there will be IPv4 header. By looking IPv4 header, how you will identify actual traffic? How you will get to know that this is a traffic of ICMP by checking IP header? There is one field called protocol field, right? Inside the protocol field, there will be information about ICMP protocol. There will be protocol number of ICMP. If I will open IP protocol, IP header. So IP, inside the IP header, what is the protocol number? 1. That means actual message is, actual packet is ICMP. ICMP packet is encapsulated with IP. In the same way, inside the GRE header, inside the GRE header, inside the outer IP header, protocol number is 47. 47, and 47 is the protocol number of GRE. That means actual packet for this outer header is what? GRE.
GRE, it's a protocol, right? Okay. Okay.
Yeah, right, correct. It is a protocol, right? That means here actual packet is not ICMP, actual packet is what? GRE. So when router will open GRE header, but this protocol field, it will come to know that GRE header is encapsulated with actual packet. So router 2 will remove this outer header, this outer header, this outer header. First of all, it will check destination in the outer header. Destination is 16.1.1.1. my IP address. Let me check protocol field. In the protocol field, value is 47. That means protocol is what? GRE. So then router will come to know that actual packet is GRE. That means I am receiving this traffic on tunnel interface. Router knows that whenever I need to forward traffic on tunnel interface, I need to add one GRE header, and whenever I will receive traffic where protocol inside the IP header protocol number is 47, that means actual traffic is encapsulated with GRE. So router 2 will get to know that these two information are extra information. These two information are extra information. I need to remove these two extra header, and then router will open this actual IP header, and when receiver means PC server will receive this packet, right? Server will receive packet with only these two header, IP header and actual ICMP header. Inside the inner IP header, inside the protocol field, value is what? 1. That means actual ICMP packet is encapsulated, right? So R2, when R2 will receive packet, right? First R2 will open outer IP header. It will check protocol field. Then it will come to know that GRE header is encapsulated. It will remove GRE header and outer IP header. And after that R2 will forward packet to server. Right? So whenever we are encapsulating, any packet, I have to define lower, lower layer information. Lower layer information. Let's say one app on this machine, application layer is generating one traffic, right? Application layer is generating one data. So application layer will forward this data to transport layer. At transport layer, maybe TCP or UDP protocol is going to work with this data. So if TCP will work, then TCP protocol will add their header, TCP header, and inside the TCP header there is destination port number, right, to identify upper layer information. Correct, guys? In the same way, at network layer, when IPv4 protocol will add one header, there is one protocol field to identify upper layer protocol. Means at network layer, how we will identify that this is the traffic of TCP or UDP at transport layer? So there is one protocol field. Inside the protocol field, if value is of TCP, that means at upper layer I need to hand over traffic to protocol. So in the same way, when R2 will check protocol number in outer IP header, it will see protocol number is 47. Then router 2 will get to know I need to hand over it to GRE protocol, right? And then GRE protocol will decapsulate the packet, and after that forward from fast Ethernet 0/0. Clear, Vasavaraj?
Yes, yes. This GRE protocol, it will run on transport
Works
layer.
at layer 3. At layer 3.
At layer 3. Okay, okay.
Yes. GRE protocols work at layer 3. Now, see, let's say here we have lots of LAN. Here I have configured a static routing because we have only one network, right? So it is easy. But let's say we have multiple LAN here, right? Then again, configuring a static NAT is a static route is complicated. Then we need to configure what? Dynamic protocol. So see how you will implement dynamic protocol here. Between router 1 and router 2, I want to form, let's say, EIGRP neighborship. So let me remove static route configuration first. Do so run section route. Say no to this. And on router number 2 also, do so run section route, say no to this, right? Now again, PC1 cannot ping to server. You can check, you can verify it, right? Now PC1 is not able to ping because route is not available on router number 1. So this time again router 1 will forward traffic to ISP without encapsulating GRE header, right? Because route is not available with exit interface tunnel. So on R1 guys, now I am going to configure EAGRP. Router EAGRP, S number let's say 10 and the network 10.1.1.0 wildcard mask 0.0.255. Now what will happen? Router 1 will encapsulate one hello message of EAGRP, correct? And it will forward that hello message from which interface? From tunnel interface. So in the capturing again you can see hello messages, right? Hello message of EAGRP. Again this hello message is encapsulated with GRE header. How? Because see, this is hello message of EAGRP. R1 will generate this hello message. Source IP address will be 10.1.1. Destination IP is multicast, right? Router 1 will check their routing table to forward traffic to
Multicast address.
right, to forward the traffic of EAGRP hello message, right?
Yes.
Now EAGRP is enabled on which interface? Tunnel interface. So router 1 need to forward traffic from tunnel interface. So if I need to forward any traffic from tunnel interface, I will encapsulate GRE header. Yes or no? And again in the outer IP header you can see source IP is 15.1, 16, destination IP is 16.1, right? Getting my point? Concept is very simple. Whenever exit interface is tunnel interface, encapsulate GRE header. Okay. In the same way on router number 2, also I will configure EAGRP. Router EAGRP S number 10 and network 10.1.1.0 wildcard mask 0.0.255. Soon EAGRP neighborship will come up. You can see the log message, right? So IP EAGRP neighbor. We have EAGRP neighborship between router 1 and router 2. Now we can advertise LAN in EAGRP, right? So IP EAGRP neighbor. Neighbor is on which interface? On tunnel 1 interface, right? Now on router number 1 I am going to advertise my LAN in EAGRP by running network 192.168.10.0 wildcard mask 0.0.255. So IP EAGRP topology, right? And on R2, so IP EAGRP topology. R2 have received this network, so IP route EAGRP. Yes, it have learned this network through EAGRP protocol. On which interface? Exit interface is tunnel 1. Again, if router 2 need to forward traffic in this network, exit interface is tunnel interface, it will encapsulate GRE header, right? And on router number 2, router EAGRP S number 10, sorry, router EAGRP S number 10, network 192.168.20.0. So IP EAGRP topology, right? On R1 you can verify. So IP route EAGRP. Yes, I have received this network. Again PC1 can ping the server. In the same way on tunnel interface we can configure what? OSPF. If you want to configure OSPF, simply remove EAGRP configuration. Say no. Router EAGRP S number 10. On router number 2 also no. No router EAGRP S number 10. Say router OSPF process 1 router ID 1.1.1 exit. On router number 2 router OSPF 1 router ID 2.2.2. And now we can advertise interfaces in OSPF. Interface tunnel 1 IP OSPF 1 area 0 On daughter number 2, interface tunnel 1, IP OSPF 1 area 0. Soon OSPF never see will come up. You can see. So IP OSPF interface brief. OSPF is enabled on tunnel 1 interface. So IP OSPF neighbor. We have neighbor 1.1.1. Now we can advertise LAN network in OSPF interface fast Ethernet 0/0 IP OSPF 1 area 0. On daughter number 2 also interface fast Ethernet 0/0 IP OSPF 1 area 0. So IP OSPF database, right? Okay guys, now again PC1 can ping server. See, so this is how we make communication between two private network over public network, right? Let's say one side is in Delhi and one side is in Bangalore.
GRE, is it secure one or not? GRE.
Not. This one is not secure one. For secure one, for security purpose, here you have to configure IPsec. Here you have to configure IPsec on this tunnel to secure it. If you are able to see here in the capturing, if I am forwarding ICMP packet from the tunnel, you can see we are able to read all information, right? So this is not secure.
Because here we are not doing any authentication process, right?
Correct. For that, on this tunnel you can configure IPsec.
Yes.
Can you do that?
No.
On here.
No. Here I am going to configure not DMVPN. This is what? Point to point tunnel. Let's say like this, one side is in Delhi and one side is in Bangalore. Like this we have 100 number of sites, or we have 10 number of sites in different location. Then I need to configure lots of tunnel. Then we need to configure lots of, let's say one side is here in Delhi, one side is here in Mumbai, one side is in Bangalore, and one side is in Chennai, right? All sites are connected through ISP. So here you need to configure, see, one tunnel between Delhi and Bangalore, one tunnel between Delhi and Mumbai, one tunnel between Delhi and Chennai. For each side you need to configure 3 number of tunnel, right? So for 4 side you need to configure 12 number of tunnels, right? Again, this is very complicated. Okay, so this is first problem. Like let's say we have 3 side, R1, R2 and R3. All sides are connected through ISP. Okay, so here we need to configure one tunnel, here we need to configure one tunnel, and here we need to configure one tunnel, right? Let's say this is my headquarter, this is branch 1, this is branch 2. Now if branch 1 want to communicate with branch 2, they can communicate directly, right? They can communicate directly. But let's say we don't have tunnel between branch 1 and branch 2. Then they have to communicate. We don't have tunnel between branch 1 and branch 2. Then how branch 1 and branch 2 is going to communicate? Through headquarter. And like this, let's say we have 100 number of branches or 1000 number of branches. Then configuring GRE tunnel is very complicated. Right? And let's say here we are running EIGRP. Here we have one tunnel between headquarter and branch office 1 and one tunnel between headquarter and branch office 2. Let's say this router is advertising one prefix X prefix to headquarter, right? Let's say we are running EIGRP protocol.
Recording on, right, sir? Recording.
Yes, recording is on. Yes.
Okay.
Branch 1 is advertising X network to headquarter. Will headquarter advertise X network information to branch 2? No. Why? Because of split horizon rule. Split horizon rule means you are receiving X network information on this interface, so you will not advertise X network information from same interface. So headquarter will never advertise X network information to branch 2. These are concept of EIGRP or OSPF, right? So now let me design one topology here. Why we come up with DMVPN? DMVPN. Problem in GRE tunnel is need to create multiple tunnel on headquarter. Let's say, as I told you, I have one ISP here, and this ISP is connected with multiple branch.
DM stands for DM.
Dynamic multi-point virtual private network.
Okay. Okay.
Here we have R1, R2, and R3. R2, R3. Let's say this is my headquarter. This is branch 1, spoke 1, and this one is a spoke 2, branch 2. Right, here my public IP address 1.1.1, here my public IP address 2.2.2, here my public IP address is 3.3.3. See, first requirement is all public IP addresses should be reachable with each other, and definitely in real time all public IP addresses will be reachable with each other, right? So in this scenario, if you want to configure GRE tunnel, then you need to create multiple tunnel on headquarter. Let's say we have 2 branch office, right? So we need to configure 2 number of GRE tunnel on headquarter. If we have 100 number of branches like this, we need to create 100 number of tunnel on headquarter, right? So this is first problem of GRE. We are discussing problem with GRE tunnel. So we need to configure lots of tunnel on headquarter. If we have 100 number of branches, then we need to create 100 number of tunnel on headquarter, right? And that is not scalable, or we can say it is very complex task. Second problem is spoke 1 and spoke 2 cannot communicate with each other directly. Spoke 1 and spoke 2 cannot communicate with each other directly. If spoke 1 and spoke 2 should communicate with each other directly, then you have to create tunnel, GRE tunnel between branch offices as well. So like if you have 100 number of branches, so between all branches you have to create tunnel, which is generally we are not doing. All spoke branches will communicate with each other through headquarter. In DMVPN, branch offices can communicate with other branch office directly, right, without creating tunnel between them. So this is second problem of GRE. Spoke 1 and spoke 2 cannot communicate with each other directly. Third problem, if you want to make communication possible directly between branches, then you need to create tunnel between branches also. After that, fourth problem can be what? See, try to understand guys, fourth problem, it is very important. Fourth problem is, let's say between R1 and R2, means headquarter and branch office, I am going to configure GRE tunnel. So I need to define what tunnel source and tunnel destination, yes or no? That means, let's say on router number 1 I have defined tunnel source is 1.1.1 and tunnel destination is 2.2.2. That means these two public IP address should be a static IP address, right, not dynamic. But in real time, most of the time we will have dynamic public IP address. If I will talk about my scenario, my home network Now, so my broadband router is also using dynamic public IP address. Time to time my public IP address is changing. So for GRE tunnel you have to purchase a static public IP address, and static public IP address are more costly than dynamic public IP address. You need static static public IP address for each side, because in GRE tunnel we manually define tunnel destination IP address. These are the reason why we come up with DMVPN, dynamic multi-point virtual private network. DMVPN is now DMVPN. What is DMVPN? So DMVPN is combination of two things. DMVPN is combination of two things. First thing is multi-point GRE, and second thing is NHRP protocol. We are going to use NHRP protocol for DMVPN, right? You learn lots of routing protocols, EIGRP, OSPF, REAP, BGP, right? And today you are going to learn one more protocol, that is NHRP protocol. We are using NHRP protocol in case of DMVPN.
Is it secure? DMVPN is secure?
No.
Okay.
For security, again you have to run IPsec over the tunnel.
Okay.
That is part of security.
Okay.
Okay. So one GRE can be, GRE can be here generic routing encapsulation. GRE can be point to point. GRE can be point to multi-point, or GRE can be multi-point to multi-point, right? In this scenario, here we have configured what? Point to point GRE. Here I have configured what? Point to, this is point to point GRE. Let's say I have one ISP here and some sites R1, R2, R3, R4. Let's say R2 is not here, like this. R1, R2, R3, R4. These are branches. This is headquarter. This is spoke 1, spoke 2, spoke 3. Branch 1, branch 2, branch 3. Okay. So in this scenario, if you are going to configure DMVPN, so you will configure what? Point to, this point is connected with multiple point, right? Point to multi-point GRE. If you want to configure, topology so that a spoke can also communicate with each other, then you need to configure which type of GRE, multi-point to multi-point GRE, multi-point to multi-point GRE. Okay, with the help of topology I will make you understand this again, don't worry, right? So just keep in mind one thing, that we have three types of GRE: point to point, point to multi-point, or multi-point to multi-point. Now try to understand some types of router in NHRP, roles of router in NHRP. So in NHRP there are two types of router. One is, guys, we are not learning these protocols in detail, right? Just I am giving you one overview, and in your book, in your syllabus also overview is there, right? So there are two roles of router in NHRP protocol. One is NHC and another one is NHS. NHC stands for next hop client. NHRP stands for what? Anyone? NHRP protocol stands for what?
Next hop redundancy protocol.
Reachability protocol. Next hop reachability protocol. And there are two types of router in NHRP. Like in OSPF we have multiple types of router, ESBR, ABR, right? In the same way, in NHRP, we have two types of router. One is NHC and another one is NHS. NHC stands for next hop client, next hop client, and NHS stands for next hop server, next hop server. So my headquarter router will be
So this
NHS.
NHRP we are using only DMVPN, right?
Yes.
Okay.
So NHS will be my headquarter router and NHC will be my branch offices router, right? So branch offices router is going to register their self to headquarter router, to NHS, to server. All client will register their self to server. Okay. Now I can make you understand these things practically with the help of one topology. So let me do one thing. Let me close this lab, and I think I have one lab for DMVPN. DM. Okay, let me do one thing. Let me create one lab here very quickly. Okay. Headquarter, branch 1. One 192.168.30.0/24. This is my LAN in branch 3. Okay. So R1, R2, R3, and ISP. Let me configure IP addresses first. on ISP router. So IP interface brief exclude unassign. So IP address on serial 2/0 is 15.2, on serial 2/116.2, and on serial 2/2, let's say I am going to configure 17.1.1.0/30. Okay, so let me assign IP on serial 2/2 also. Interface serial 2/2 no set, and IP address 17.1.1.2 255.255.255.252. Here loopback is not required. We can say no IP or no interface loopback 1. On each router we need one default route towards ISP, so IP route. So let me configure one default route here. IP route 0.0.0 0.0.0, exit interface is serial 2/0, and next of IP address 15.1.1.2. okay, on router number 2 IP route 0.0.0 0.0.0, exit interface serial 2/0, and next of 16.1.1.2. Then on R3 config T interface serial 2/0, say no set, IP address 17.1.1.1 255.255.255.252, exit interface fast ethernet 0/0 no set, and IP address 192.168.30.100 255.255.255.0, exit IP route 0.0.0 0.0.0 serial 2/0 and 17.1.1.2. Now you can check all public IP addresses are reachable with each other or not. Let me close the console of ISP because now we don't need to configure anything on ISP router. Ping 16.1.1.1. I'm able to ping public IP address of branch 1. Yes or no? I'm able to ping public IP address of branch 1. Then let me ping public IP address of branch 2 17.1.1.2. I'm able to ping public IP address of branch 2 also. That means all public IP addresses are reachable with each other. From router number 2, you can ping public IP address of branch 3. Sorry, 2 17.1.1.1, and you can see able to ping, right? In a step 1, you need to configure default route towards ISP on each edge router, so that after configuring default route, you should verify that all public IP addresses are reachable with each other or not. In a step 2, you will configure hub router. Hub router is my R1, right? Headquarter router. So on R1 config T, here I am going to create one tunnel. Again, I will run same command, interface tunnel 1, and then IP address on tunnel. Let's say I am going to use this subnet for tunneling 10.1.1.1. or here I am going to use 192.168.10.0/24. Let me change this LAN network. Here I am using 10.1.1.0/24. Here I am using 20.1.1.0/24, and here I am using 30.1.1.0/24. and on tunnel I am going to use this subnet. So very quickly, let me change the IP address on LAN interface. Fast Ethernet 0/0, IP address 10.1.1.1 255.255.255.0. Exit on router number 2, interface Fast Ethernet 0/0, IP address 20.1.1.1 255.255.255.0. Exit on router number 3, interface Fast Ethernet 0/0, IP address 30.1.1.1 255.255.255.0. Done. Exit. Now let's come on R1. Interface tunnel 1, IP address 192.168.10.1 255.255.255.0. submit mask, right? After that, tunnel source. Tunnel source is, what will be tunnel source? What will be tunnel source? Tell me. You have just learned GRE tunnel. Tunnel source is 15.1.1.1.
Yes.
But
Yes.
if I will define
public address.
15.1.1.1, if I will define 15.1.1.1, then I have to purchase a static public IP address. So instead of saying 15.1.1.1, I'm going to say serial 2/0. Whatever IP address is running on serial 2/0, that will be my tunnel source, right? Only tunnel destination, and in DMVPN we don't need to define tunnel destination. We don't need to define tunnel destination. Here we are going to say tunnel mode GRE multi-point. Tunnel mode GRE multi-point. In previous scenario, actually there was one command running, tunnel mode GRE point to this one, tunnel mode GRE. That command is not here. Okay, leave. In DMVPN, here we are going to say tunnel mode GRE multi-point. Means multiple points are connected with this tunnel. Multiple branches are connected with this tunnel. And then, like we configure OSPF. In OSPF, we configure what? Router ID for the identification of router in OSPF, right? Like that, here you have to configure NHRP protocol. So command is IP NHRP and network ID, right? From this range you can define any ID, let's say 1. That's it. This is configuration of hub router R1. So run interface tunnel 1. This is configuration. I have created one tunnel 1, then I have defined IP address on tunnel interface, then I have enable NHRP protocol. This is command to enable NHRP protocol, right? This is command to enable NHRP protocol. Automatically one command is added here, no IP redirects. We will discuss about this command later, or maybe I will share one video with you where I am describing this command. Then I have defined what? Tunnel source, and then tunnel source can be my public IP address also, or I can define interface also. And then after that I have defined tunnel mode GRE multi-point. This is configuration of hub router, means headquarter router R1. Network ID is similar like OSPF process ID, right? How we enable OSPF protocol on router OSPF and then process ID 1. Like that we enable NHRP protocol by running this command, IP NHRP network ID 1, right? Now then go to branch office, branch routers, like on router number 2 or on router number 3. On router number 2, interface tunnel 1. Here also I am going to create one tunnel, then IP address on tunnel in 192.168.10. Let's say 2 here, 255.255.255.0. Then tunnel source will be serial 2/0, and tunnel destination will be what? Public IP address of hub router headquarter 15.1.1.1. 15.1.1.1. So we need here still one static public IP address for headquarter only, for headquarter, right? And after that IP NHRP network ID to enable NHRP protocol, let's say 1. That's it. Then go to R3. On R3 also let me create one tunnel, interface tunnel 1, IP address 192.168.10.3 255.255.255.0, tunnel source serial 2/0, tunnel destination 15.1.1.1, and then tunnel IP NHRP network ID 1. This command will enable NHRP protocol. Now we need to map destination tunnel IP address and destination public IP address. See guys, these router like branch offices, as I told you, in NHRP there are two types of router. One is NHS and another one is NHC. One is NHS and another one is NHC. NHC is my branch offices router and NHS is my hub router, headquarter router, right? So to map what we say NBMA address, so IP interface brief, see tunnel interface is up or down, up. On router number 2 also, so IP interface brief, tunnel interface is up. On router number 2, so IP interface brief, tunnel interface is up. And can we ping tunnel interface from router number 1? Let me check. Ping 192.168.192.168.10.2. From R3 I am pinging, sorry, from R1 I need to ping 192.168.10.2. Ping is not working. Can anyone tell me, guys, why ping is not working? Because route is available and exit interface is still tunnel 1 interface. So IP route, this network is connected on tunnel 1 interface. So again, if I am pinging to any IP address from this network, right, router 1 will forward traffic from tunnel interface. It will encapsulate header. Actually here, you know, this router R1, so IP, so run interface tunnel 1. R1 know what is tunnel source IP address, but R1 don't know what is tunnel destination IP address, right? Tunnel destination means my remote public, what is my remote public IP address, and what is remote IP address on tunnel interface, what is remote tunnel IP address. So R1 know remote tunnel IP address. When you are pinging 192.168.10.2, which you are telling to router number 2 what is remote tunnel IP address, but R1 don't know what is the public IP address, that is called NBMA address. That is called NBMA address. Means router 1 don't know what is NBMA address of branch 1 and what is NBMA address of branch 2. So here I have to tell to router 1 manually what is the NBMA address, means public IP address of branch 1, and what is public IP address of branch 2. So here I need to run one more command on router number 1. Again go to interface tunnel 1 and then say IP NHRP map, IP NHRP map 192.168.10.2. See, I will map this IP address with public IP address of tunnel on router number 2, that is 16.1.1.1. IP NHRP map. Actually we are mapping tunnel destination IP address with public IP address with NBMA address, right? After running this command, and before running this command, see, if I will say no to this command and do so, there is one verification command, do so IP NHRP, do so IP NHRP, so IP NHRP. Yes, we are not able to see any output here. Interface tunnel 1, and let me run this command. Sorry, interface tunnel 1. So IP NHRP. Now you can see the NBMA address of 192.168.10.2 is 16.1.1.1. Now if router 1 need to forward packet to this IP address, right, it will put this IP address as a destination IP address, right? When it will encapsulate extra IP header, when it will add extra IP header, in extra IP header destination should be what? 16.1.1.1. Earlier router was not aware about the destination public IP address. So on the hub router we have to map, right, NBMA address and destination tunnel IP address. In the same way, for branch 2 also I have to map NBMA address and tunnel IP address. Interface tunnel 1 and IP NHRP map 192.168.10.3 and NBMA means public IP address of branch 3 is 17.1.1.1. Yes, and now show IP NHRP. Now you can see inside the NHRP table of router 1 we are able to see tunnel destination IP address with public IP address, right? And now if router 1 need to forward traffic to 192.168.10.3, right, it can encapsulate the packet, right? Now we can again run, first of all let me check the connectivity. Ping 192.168.10.2. see, now I am able to ping. Now I can run what? Routing protocol. We can configure what? A static route. We can configure any dynamic routing. Even we can configure BGP. This is DMVPN. Now to exchange these prefixes, LAN prefixes, we can configure what? Dynamic routing protocol. On router number 1, router EAGRP yes number. Yes.
If you have 1,000 branches, do we need to give this mapping for each for the 1,000?
We have one, this command interface tunnel 1 IP NHRP. All branch offices are going to share their NBMA address to headquarter. All branch offices are going to, on branch offices we need to run this command, one command, interface tunnel 1 IP NHRP NHS, IP NHRP NHS, and I will tell the IP address of headquarter, right? NHS. So all branch offices are going to register their self to headquarter router. Yes, on all branch offices you have to run this command. Okay. Now on router number 1 we can run dynamic routing protocol like EAGRP. Router EAGRP is number 10, network 192.168.10.0 0.0.0.0.255. On router number, sorry, I have run this command on router number 3. No, router EAGRP is number 10. Let's say router number 1. Router EAGRP is number 10, network 192.168.10.0 0.0.255. And on router number 2, exit router EAGRP. Router EAGRP is number 10, network 192.168.10.0 0.0.255. Soon EAGRP neighborship will come up. EAGRP neighborship will not come up. Can anyone tell me, guys, why EAGRP neighborship will not come up? Just think.
Because there is no reachability between
No
R1
reachability.
and
Reachability is there, na? R1 is able to do ping. Forget about this log message. Ping 192.168.10.2. So reachability is there, brother. Do so IP EAGRP neighbor. Q count is 1. That means neighborship is fluctuating. In EAGRP we discussed Q count. What is Q count? Right? So here Q count is increasing. That means EAGRP neighborship is fluctuating. Now why? Okay, let me do one thing, debug, or what we can do, let me capture this link. Hello message. Which router is sending this hello message? 16.1.1.1 means router number 2. Destination is what? Destination is multicast. In outer header source IP is public IP address, destination IP address is again public IP address, right? Let me open hello message of router 1.
NHRP allows multicast.
No. Yes, but here again we have to actually map multicast into unicast. In NHRP we have to map multicasting into unicast. See, this is hello message of again. Destination IP is, guys, here. See, in the hello message of router 1, destination is multicast. In the outer header, here destination should be what? 16.1.1.1. Here destination should be what? 16.1.1. Otherwise ISP will discard this packet, yes or no? ISP will not forward the hello message of router 1 to router number 2, because router 1 is forwarding hello message on multicast address in inner header also and in outer header also. So on R1 actually we need to add one more command, config t interface tunnel 1 IP NHRP map multicast to 16.1.1.1. Now whatever multicast traffic router 1 will generate, NHRP protocol will map that multicast to this IP address, and we need to do same thing for other branch also, like for 17.1.1.1. and now EAGRP universe will come up. Clear? IP again, if you will check hello message of router 1. So now this is hello message of router 2. Yes, now you can see it is sending unicast hello message in outer header. Again in the inner header destination is multicast, right? Now let me close this capturing and let me show you EAGRP neighborship. So IP EAGRP neighbor. Now Q count is 0. We have EAGRP neighborship between R1 and R2. On R3 also router EAGRP is number 10 and network 192.168.10.0 while karma 0.0.255, right? Here also EAGRP neighborship will come up, and now we can advertise LAN network in EAGRP. Then all branches can communicate with each other. Right? And like this, like EAGRP, we can configure other routing protocols, so OSPF or BGP. On router number 1, router EAGRP is number 10, say network. Let me advertise LAN 10.1.1.0 wildcard 0.0.255. Right? On R2, network 20.1.1.0 0.0.255. On R3, router EAGRP is number 10, network 30.1.1.0 0.0.255. So IP route EAGRP, it have LAN 10 network 10.1.1.0/24 R1. So IP route EAGRP, it have LAN both 20 and 30 network, right? And R2, so IP route EAGRP, it have LAN 10 network, right? Means router 2 have not LAN 30 network and router 3 have not LAN 20 network because of a split horizon, right? R2 is advertising 20 network to R2, so R2 is learning 20 network on serial 2/0, so it will not advertise same network from receiving interface, from tunnel interface, right? So what we can do here, we can disable a split horizon rule. So see, R1 is learning, R2 is learning only 10 network, right? In the same way R3 is learning only 10 network. So on R1, go to R1 and interface tunnel 1, say no IP split horizon for EAGRPS number 10. And now on R2, so IP route EAGRP Now yes, it is learning 30 network. Now we can check reachability also from headquarter. Ping 20.1.1.1, source 10.1.1.1. Yes, I am able to ping 30.1.1.1, right? From branch to branch also we can verify connectivity. Ping 20.1.1.1, sorry, 30.1.1.1, and source 20.1.1.1. So ping is working. Okay, so this is guys DMVPN. Tomorrow I will start switching module.